So in this case, we're dealing with a life insurance policy. The possible X values are 0 and 100,000. The possible P of X's are 0.995 for 0 and 0.005 for 100,000. So the process is the same as the last examples. We're going to start by calculating the mean. The mean, remember, is the sum of X times P of X. So in this case, just like the last, we're going to create a column X times P of X. 0 times 0.995 is 0. 100,000 times 0.005 is 500. We sum this and we get 500. So the mean in this case is simply 500. Keep in mind that we are dealing with money here. This is a meaningful value in this case because this is the average payout. So for example, if you were to charge $500 for these policies, then the company would break even, not counting any overhead or anything like that. So you need to understand how to find a discrete probability or the mean of a discrete probability distribution in these kinds of cases. To find the standard deviation, we start with the variance. Now this is a much less useful value, but it is something that you need to be able to calculate. So just like the last example, we square our X values. So 0 squared is easy. When you square 100,000, you do get a very large number. You get 10 billion. And actually we don't need to sum that, but we do need to sum of X squared times P of X. So make sure you multiply the correct columns, X squared and P of X. Get 0 times 0.995, which is 0. And you get 10 billion times 0.005, which is 50 million. So the sum of X squared P of X is 50 million. So for the variance, you take that 50 million and you subtract the mean squared. The mean in this case, remember, is 500. So you subtract 500 squared. That'll give you 49,750,000. So that means your variance is 49,750,000. To get standard deviation, we take the square root of that. Which is 7,053.37. So like I said, that's not the most useful number in this case, but it is something you need to be able to calculate, and something that will be important in the next couple chapters is how we utilize the standard deviation. One thing you can notice here is you should kind of expect this to be a reasonably large number because your X values are 0 and 100,000. So since those values are pretty far apart, you would expect to have a reasonable size standard deviation.